Good afternoon, everyone. Thank you for joining us today. My name is Jamie Sullivan. I'm a Senior Solutions Engineer with the Dynatrace team based in Auckland, New Zealand. Our discussion for today, accelerating AWS cloud migration and modernisation with AI-driven observability. Regardless of which industry you're in, the tech stack that runs your business will be modernising in some form or another. And so for today, we'll step through what's driving migration and modernisation forward. Some of the common challenges and pitfalls along the way, why observability needs to be the cornerstone for successful modernisation, and optimising for cost and performance post-migration. Setting the scene in terms of who Dynatrace is. Dynatrace provides a platform-based approach that delivers analytics and automation for unified observability and security. This platform-based approach simplifies the complexity of modern cloud distributed services with a broad set of use cases across observability, application security, business analytics, and automation. I won't spend too long on this one, but according to Gartner, we are the clear leader in the application performance management and observability quadrant amongst 19 other vendors. That's in both ability to execute, completeness of vision, and critical capabilities. We see our key differentiator being that we truly have a platform-based approach. That means that whenever we make improvements to Dynatrace, those multiple use cases that I just mentioned benefit from that. Dynatrace supports full observability of all AWS services. The metrics and data that we do ingest from AWS all benefit from the Dynatrace platform and our AI to spot anomalies, detect problems, and fix them quickly. So we're not just presenting data on a dashboard. When we need deeper code-level visibility and application performance management, we can deploy Dynatrace's one agent into the likes of managed Kubernetes environments, EKS, EC2 instances, and other AWS services. But what's driving the need for AI-driven observability? Well, if we consider the modernization that applications are going through, and what used to be delivered on 2 or 3 virtual machines, a front end, a back end, and a database, is now dozens and dozens potentially of microservices and containers, each generating metrics, events, logs, and trace data. So there's been an explosion in the volume of data and noise that you and I, that engineers, that our tools has to deal with. And the typical approach that we see here is to throw more tools, more dashboards, more people at the problem. But as we're probably discovering, that doesn't mean that we have a greater understanding or context into our environment. In fact, the opposite is often true, because it takes time away from our technical talent because they're having to water and feed, manage the tools, and understand the data. So a true observability platform needs to be able to organize all of this data for us, to spot anomalies, detect problems and patterns, identify problems and root cause them quickly. So with the Dynatrace platform, we can ingest data from any source, whether it's our on-premise bare metal server, whether it's virtual machines, cloud and cloud native. The likes of Dynatrace's one agent can sit across front-end services, browser and mobile applications, back-end services, infrastructure and hosts. Then we have our ingest API for visibility into third-party SaaS services, extensions on the Dynatrace hub for observability into external vendors. We're a big contributor to open telemetry as well, and with our ecosystem integrations with the likes of AWS and CloudWatch and other hyperscalers, we truly can support observability into any environment. But what makes all of this possible is Grail. So Grail is our massively parallel processing data lake for all of that observability, security, and business data. Grail currently supports 500 terabytes of ingest per customer per day. That will increase to 1 petabyte through the course of this year. Pre-processing rules make it simple to extract metrics and events from log data. We can support data masking on ingest or assign different log files to different storage buckets with retention periods all the way up to 10 years. Our additional context is provided by Davis AI, understanding the data in context. Smartscape is an example of this. It's a real-time topology-based tree of all of our dependencies, both vertically from front end through to back end, horizontally from service to service, process to process, host to host. And then for data science and log analytics use cases, the likes of notebooks and Dynatrace query language make it simple to extract answers to perform explorative analytics on top of that data. And the differentiator here is that as we need to explore that data, we don't need to worry about rehydration, reindexing, moving log data between different storage tiers. And that just supports more agile, faster decision making. And when we bring all of this together, we really start to drive observability, security, and automation use cases, or essentially answer-driven automation. Underpinning the Dynatrace platform is Davis AI, and we're not just on the AI bandwagon here. Our predictive and causal AI has always been a key differentiator for Dynatrace, spotting problems and fixing them quickly. But now with Copilot, we can talk to Dynatrace using natural language for data exploration use cases, for creating dashboards. But our existing causal and predictive AI can enhance the capabilities of Copilot for automatic problem remediation or to act as a trigger for user input to enhance the capabilities of Copilot. And this is across a wide variety of data types, from metrics, logs, traces, topology-based information. But back to the theme for today. What's driving migration and modernization forward? Well, as we know, for businesses to stay competitive, they need to continue innovating. To enable this, we've seen the shift from monolithic services to cloud native and microservices to overcome technical constraints, additional flexibility, portability, scalability of services. Our DevOps and SREs enable the automation that we need with continuous integration, continuous deployment to release higher quality software, more resilient software faster. But you can't manage what you can't measure. And so for this level of automation to work, we need observability feedback loops in place to measure these incremental changes that we're making along the way. And Dynatrace's Site Reliability Guardian is just one example of this. You can think of it as your quality gate to measure these releases and these improvements as you're making them. And then when we combine this with the optimization and modernization services that AWS has available to right-size workloads, to pivot from commercial off-the-shelf to open source equivalents, to modernize, we can really start to accelerate your migration, your modernization journey forward. But the challenge that we see is that a lot of organizations tend to stop at the migration, the rehosting phase, and never realize the benefits. So we'll step through how we can help you modernize faster today. But a lot of the challenges that many customers, probably yourselves, experience along the way include the diversity of operating systems, applications, databases, and the inherent compatibility considerations between them. Most enterprises have legacy applications, whether it's been built in-house, whether it's commercial off-the-shelf, that everyone's too afraid to touch for fear of breaking things. And then we consider that business data and applications, we can't leave data behind during migration. It needs to be kept up to date and in sync to minimize downtime and disruption. And the fact that from a project PMO perspective, obviously pressures to deliver on time and on budget. As Werner Vogel's Amazon CTO has stated, everything fails all of the time. That failure comes at a real personal cost in terms of the sense of pressure and anxiety potentially, the sense of expectation from the business, from the users to fix problems quickly. If I could just get a show of hands here, who could tell me what 99% availability equates to in terms of average downtime hours per year? Show of hands, anyone? Well, at 99% availability, we're looking at about 87 hours of downtime per year. Triple nines, we're looking at about 8 or 9 hours downtime. Even at 4 nines, 99.99% uptime, we're at about 50 minutes downtime per year. That downtime comes at a commercial cost to businesses on average of about $42,000. Then we consider the productivity impact to our technical teams, our SREs, our developers, our engineers. Instead of working on new features, committing code, innovating, they're fighting fires, fixing problems, and troubleshooting. The brand impact, because our customers expect software to work perfectly the first time, all of the time, and if it doesn't, there's real negative consequences in terms of our brand and brand perception. So how do we go about planning our migration for success? What are some of the considerations? Well, many of us have heard of the 7 R's when it comes to migration strategy. We might discover as part of our assessment and discovery that certain workloads are best left in place or retained in their current state. We might also discover that other applications are best off retired or decommissioned. But for a majority of applications, they'll fall into one or two key migration strategy buckets. The all or nothing or waterfall approach. This is also known as replatforming or modernization of those workloads in place. If we're honest with ourselves, this approach is often driven by fear. The fear of making too drastic changes too soon and causing disruption. The challenges that we see with this is that project engineers working on the project lose interest. They want to start working on other things. From a cost perspective and project perspective, it's hard to track, and there's little short-term benefits gained. But if we compare this with the move and improve agile methodology, where we combine the classic lift and shift or forklift approach of workloads, but the important distinction here is that we don't just lift, shift, and leave, but we lift, shift, and then continually, iteratively optimize and modernize those workloads. The benefit here is that during migration, our teams will have gained a lot of competency and familiarity with AWS's cloud services that make it much simpler to modernize after migration. We also avoid the complexity from an operational perspective of having to maintain our legacy data center and our new target cloud environment in parallel, as well as the cost implications because of that. And AWS's application migration service can simplify, expedite, take away a lot of that complexity when it comes to migration. So with the application migration service, we have the flexibility to migrate from any source, whether it's our traditional on-premise data center, whether it's from another cloud provider, or whether it's even between AWS regions. It has support for a wide variety of operating systems, applications, databases. And because the synchronization is asynchronous, continuous, and at the block level, we don't need to worry about leaving data behind during migration, which means that disruption downtime during cutover is less of an issue. We're leveraging AWS's familiar management console and tool sets. That means that expertise and specialist skills, again, less of a challenge when we're using application migration service. So now that we know what the application migration service is, let's have a quick look at how it actually works. So on the left-hand side, we deploy lightweight replication agents to those workloads. Those agents don't require a restart, minimal performance overhead. They start synchronizing data that's encrypted with AES and TLS encryption, but they start synchronizing that data from those source volumes on the left-hand side to target volumes on the right-hand side. The application migration service will automate and orchestrate the spinning up of lightweight EC2 instances that act as replication servers. So those replication services receive the incoming traffic from those source disks, the incoming data, and replicate it to the target EBS volumes there on the right-hand side. Once that data is synchronized, we can then proceed with our test or production cutover. Again, the application migration service will automate the spinning up of EC2 instances that are sized based upon our launch settings. Once we've tested, validated, proven that our test cutover works, we can proceed with our production cutover. And again, that process is simplified and expedited. Typically, the spinning up of those production EBS volumes occurs over the course of a few minutes, minimizing downtime. Again, having proven and tested that our target environment's working, we can then proceed with decommissioning and our modernization and optimization activities. But it's important that we integrate performance and observability data before we migrate. And this forms part of the planning framework, the assess, mobilize, migrate, and modernize framework that AWS suggests all customers go through. The recommendation here is that we perform the assessment as early on as possible. Through the maturity assessment analysis, we gain an understanding of our strengths and weaknesses across people, processes, platforms and tools, governance models, security. The gaps and weaknesses that we identify here, we look to remediate before we hit migration. During the mobilize phase, we look to identify some target application workloads, again, identifying any technical constraints, performance bottlenecks, etc. But the whole idea with these test migration groups is that we embed a culture of automation and agile delivery culture. During this particular phase, during the mobilize phase with these test applications, we carry the learnings and the experience we gain from this through to the wider enterprise-wide mass-scale migration. It's important, though, that we have a clear understanding of our environment before we migrate, that we're truly experts to help us make more informed, accurate decisions around migration. How are things hosted? What are the dependencies between our logical services and our physical infrastructure? With Dynatrace's digital experience monitoring, again, important that we have a clear understanding of user experience and user journeys, all the way from their browser and mobile-based applications to back-end services, infrastructure and database layers. And as we're making these incremental changes, being able to identify any performance impact, regardless of where it occurs in that user journey, is crucial. And we might discover as part of our assessment, as an example, that some users might benefit from having the front end closer to them within a particular AWS region. Well, in order to make those types of architectural decisions, we need to truly understand the interdependencies between all services, between our front end, our back end, our infrastructure and host layers. In this example, we're looking at Dynatrace's service flow. This is an automatically created representation of transactions and dependencies from the front end through to the back end. We might discover as part of our analysis that certain services can be split off, isolated, and migrated independently in their own migration group. Others, such as this example, will have tighter dependencies between front-end and back-end services. And we need to truly understand the performance, the latency, the throughput between each of these service tiers, but also how those logical services are physically hosted or virtually hosted to make informed decisions around migration groups and to minimize the impact. Don't forget back-end and database. So have a clear understanding of back-end database performance requirements, the resource consumption, identify and clearly understand upstream applications and service calls that rely on that database. Ideally, we get as granular as being able to identify our most expensive SQL statement. In this example, we're looking at a classic select star from example, so that's often a good place to start. But the point here is that those suboptimal statements, when they're on-prem, they equate to effectively an increase in response time and execution time, an increase in CPU cycles. But as we migrate those suboptimal queries into the cloud, all of a sudden those increased CPU cycles mean that we have a direct increase in cost after migration. So have a clear understanding of your back-end services before you migrate. Integrating application security across all environments at all stages of the software delivery lifecycle so that we can catch and spot vulnerabilities quickly, ideally before they hit production. and providing those vulnerabilities and context for developers, for security engineers and operations teams to understand the impact. Did we detect any traffic from the internet? Did that vulnerable library make exit calls to a back-end database? By understand vulnerabilities and context, we can prioritize remediation. And with our integration with Sneak, we're receiving vulnerability feeds in near real time, and we're able to, for example, identify the remediation library to fix these vulnerabilities quickly. Now that we have a clear understanding of our environment with Dynatrace, we can use Dynatrace's data and import it into the inventory management service in AWS. Using inventory management service, we can define things like the sizing of EC2 instances. We can deploy the replication agents to our workloads and define our migration waves and groups. So you can think of this as your one-stop shop effectively for migration and management of that process. But we can take that a step further by leveraging the Migration Hub Strategy Recommendation Service and using Dynatrace's data and importing that into MHSR, we can make accurate recommendations around the appropriate migration strategy for particular application groups, whether there's any inherent compatibility considerations that we should be aware of, whether we should take advantage of any optimization services during migration. So make the most of the Migration Hub Strategy Recommendation Service and leverage Dynatrace's data for more accurate recommendations. Again, ensuring that we integrate performance, observability, and security after migration. So with post-launch modernization actions, we can ensure that the new workloads, EC2 instances, as they are spun up, are observable and secure by design. So with post-launch actions, we can ensure that one agent is deployed with those new instances as they are spun up. Other post-launch modernization actions that we may want to consider. So these are just some examples that will depend on your use case, your environment, but some examples here might include enabling DRS for resilience of services between AWS regions. We might want to consider making the most of refactor spaces to iteratively, gradually modernize and containerize our monolithic applications. Consider using Amazon's machine images or AMI to create a replica of our production environment into a lower environment, avoiding having to migrate these lower environments separately and avoiding the complexity, but also the data ingest costs associated with that. Again, just some examples here to get you started. Other post-launch actions from third-party vendors, again, these extend the capabilities of those new workloads as they are created. Deploying fleet management from a Dynatrace perspective, ensuring that observability and security is baked into those workloads as they are spun up. Then optimizing those resources for cost and performance post-migration. With Compute Optimizer, we can make accurate right-sizing recommendations around cost and performance, but also we can leverage Dynatrace's data and metrics as an input into Compute Optimizer for more accurate recommendations around sizing of CPU and memory, ensuring that resources aren't over-provisioned and thus costing more once we've migrated, or under-provisioned and thus impacting user experience and performance. So make the most of Compute Optimizer and make the most of Dynatrace's data as an input for more accurate recommendations around sizing resources. So key takeaways from our discussion today. Click, click. So from a planning perspective, ensure you're planning across the entire organization, from people, processes, platforms, and tools. The weaknesses and gaps that you identify, have a plan to remediate them going into migration. Ensure that you get the buy-in of the wider business, that the stakeholders are on board with you as part of that journey. Start small with some test migration groups and applications to embed an agile delivery culture and change management process. Don't just lift, shift, and leave those workloads. So continue to iteratively modernize and optimize for cost and performance post-migration. And from a DevOps perspective, embrace shifting left. This one's a bit of a given, but use automation, CI/CD pipelines to release higher quality, more resilient software faster. But in the analogy that we have here, don't fly blind throughout that process. Ensure that you have observability, ideally Dynatrace's observability, helping light your way, helping you navigate along your modernization and migration journey. So that concludes the session today on AI-driven observability, why it's a mandatory requirement for successful migration and modernization. The Dynatrace team will be on booth G8 through the course of today and tomorrow, so come and have a chat to the team, ask for a demo. There'll also be drinks with the Red Hat team at the Harajuku Gyoza Bar from 6 p.m. tonight, so come and get a pass. We hope to see some of you there today and tomorrow. Thank you.
Thank you so much for that, mate.
Thank you. Thanks.
I think everyone would definitely love to have a beer after a very, very good session from Jamie. So thank you very much. Guys, please, feedback is very important. Be sure to rate this session on your Summit app. Thank you very much for attending. The next session will be in this room at 2:20. Thank you.